Great to see you all here. So I just wanted to talk a bit about what we're seeing from some teams, who are building and shipping AI enabled applications and what kind of demands that puts on the user experience. And rather than just kind of describe this in the abstract, what I'm going to do is use our new AI transport landing page as a guide. So this went live this morning. It's available at ably.com/AI-transport. I think it lays out what becomes possible when you have a dedicated real-time transport layer underneath your sort of agentic application. So I'll walk through that, and then I'll show a quick demo at the end that we built using Ably and a healthy dose of Claude today, and show how you can use Ably to sort of achieve some of these aims. So let me share my screen. Yeah, so as I said, this page went live today. Feel free to take a look at your own leisure. What I'm going to do is just talk a little bit about some of these sort of the primitives that underlie some of the experiences that go into these AI-enabled applications. So the first thing, obviously, is that conversations stay in sync across devices, and a big part of that is resumable sort of reliable token streaming, right? So at the lowest level, you're streaming tokens, and when you're sending a high rate of tokens to the end user, you want a transport layer that's resilient to sort of end client connectivity problems. Ultimately, no matter how great your infrastructure is, you can't always control for the connection stability of your end users. And things like connection recovery and resume, where when the connection drops, and then some tokens are delivered in the middle, and then the user's connection is reestablished, you don't want the user to have missed any of those tokens in the meantime. And so, this is the kind of thing that Ably was kind of built for. People use these features all the time, but it becomes very relevant, right, for token streaming. I'll touch as well on sort of multi-device, multi-tab continuity. The conversation you're having with the agent ultimately, can live, if you have this sort of real-time transport layer, can live in the channel rather than on any sort of individual connection. And what that means is, any device using the same channel name sees the same conversation history and the same live stream of updates. And that kind of gives you out of the box kind of, multiple tabs, multiple devices, multiple users that can subscribe to the channel and see a sort of consistent, synchronized view of the conversation. Rejoining an instantly hydrating state, users might navigate away and or refresh the page, and being able to sort of hydrate that conversation history while also having continuity with any live updates that are currently happening, right? And this can be applied to message history, right? Of course. So Ably provides the ability to sort of retrieve messages from history and to do so in a way that's continuous with the live tokens that are arriving at on the channel. So you can sort of hydrate the chat history and also receive those live updates. But this might also apply to sort of, durable structured state, for example. So if you have sort of more structured data that's being updated in real time, the ability to sort of load that structured data and subscribe to subsequent changes to it. Live steering in barge-in, this is about, bidirectionality, users being able to, use that context from the live updates they're seeing about, what agents are doing, what's happening in the back end sort of, agentic architecture, and use that information to then steer the AI to take some different path, right? So having insight into the visibility of what steps the agent is taking is super important, but then also having that bidirectional sort of interaction with the agentic system to be able to send messages to say, no, you need to go in this direction, or don't do this, do this. And having a sort of a shared channel that both user and agents can share communication over really helps with that. Agent progress and reasoning. We talked a bit about this, but it's being able to see the reasoning steps that's being performed by the model. But quite interestingly, there's different places in an agent sort of life cycle where this can happen, right? It might be when in a particular, call to a model is returning to reasoning steps on the API. It might be, that particular model call is associated with some thinking that you want to expose, or it might be even an external tool call and you want to see progress of that, maybe paginating data or something like this. That's kind of outside of the actual model invocation itself. And so having the ability to sort of have, these sort of subscribable data structures, whether that's structured state or messages, helps sort of with surfacing that real-time progress updates and allowing independent agents to make those contributions sort of independently, right? Without having to orchestrate through some central orchestrator agent or something else. Like each specialized agent can contribute that state to surface the progress updates that are relevant to the user, independently, even if some centralized agent doesn't care about the intermediate steps. Human takeover, Matt talked a little bit about this, but it's, when a human then steps into the conversation, they need to obtain, the context, the conversation, what's happened, what steps has the agent taken so far, what has the user been requesting it to do. So really, this is just about exposing that state to another party, right? To expose that state to the human who's taking over that task, and then being able to reply in the same thread, override decisions, and making those updates also visible to both user and agent. Multi-agent awareness. Having these multiple agents publish into the same sort of conversational context, where these agents have their own identity, being able to see, messages from each other, but also and updates to state, progress and so on in real time. So that, they have that context to be able to sort of coordinate with one another rather than sort of collide. Presence awareness is a really interesting one because, this came up quite a lot where you think about, an agent is doing some task, especially when, executing and doing that task is expensive. It's very helpful to know when the user is online and is waiting on that response, versus when they've gone away, and so features like Ably Presence, which allow you to sort of the agent to subscribe to the online status of the user, can allow the agent to then make a decision based on the fact that the user's gone away. So, for example, you might decide to publish a push notification when the result is available. Shared app and agent states. It's interesting because this is where sort of states becomes kind of bidirectional, right? It's not just state from agents that you might want to synchronize to users. It might also be, other shared state that the user is manipulating that you want to make available to agents. It might be state the user is manipulating. It might be just context about where the user is in the application, what they're editing, what's selected. And all of that kind of app context can be made available through sort of subscribable data, to the agents that can take sort of appropriate decisions based on the actual user's context. LLM and framework agnostic, again, Matt sort of mentioned this, but there's lots of different stacks lots of different technologies that you might combine in different ways depending on what your application is trying to achieve. And really, you don't want to have to be keeping up with the pace of change of things in the model ecosystem. That kind of needs to be decoupled with the actual end distribution of the state and the interactions with your end clients, right? So having this kind of abstraction where you're quite deliberate about what you're synchronizing to end users, but also you're independent of which underlying stack or model providers you're using, allows you to create that decoupling through a real-time transport layer. Tool calls. This is kind of where the bidirectionality can also come in. It might be seeing progress updates from tool calls that agents are making, but also human in the loop. Human in the loop is quite often implemented as sort of a tool call to the user, which the user resolves. And again, having bidirectionality there on the channel is quite useful for that. and being able to do things like correlate responses, right? So the agents delivered a tool call to the user, and there's some ID associated with that tool call, and then the user being able to respond while other things are happening on the channel, and sort of correlating its response using something like an ID in a message header. And finally, this sort of agent to agent interaction. You know, a lot of the time, there's lots of things emerging in sort of the space of agent to agent coordination. But what we have, heard is useful is sort of being able to see the shared context about what different agents are doing. And again, having everything sort of flow through a sort of shared transport makes it possible to surface this sorts of information to different agents. So this is kind of the overall of some of the kind of the core primitives or the core functionality that sort of go into building all sorts of different types of user experiences. What we've realized is Ably enables a lot of these things already. So what we're trying to do is sort of put together a lot of documentation and so on that shows how to achieve these things using Ably primitives. So we do hope to have something more to share there soon. What I'll do now is just quickly show sort of a demo we put together, sort of just using existing Ably APIs to build some of this functionality into a real app that you can sort of play and experiment with. So let me have a quick look here. So what I did is I took an example of sort of a classic kind of multi-agent application, a sort of a holiday planning application. The sort of architecture is you've got a web app on the front end, and there's this orchestrator agent that the user sort of initializes its session with a sort of an HTTP request to initialize a session. And after that, all communication happens via Ably. And this communication is bidirectional. So the user can send messages to Ably to deliver to the orchestrator agent. The orchestrator agent streams tokens back to Ably to deliver that to the web client. And then there are these specialized agents which the orchestrator uses to, break down the tasks that it needs to do to plan the holiday, delegates those tasks to these specialized agents, and the specialized agents can then contribute progress updates directly via Ably Live Objects in this case, without the orchestrator agent, needing to manage the incremental progress updates, instead concerning itself just with the result, right, which is the thing that it needs to carry on with its job. And so that decoupling still allows the user to sort of see those incremental updates. We're using features like presence as well for online status. But what I think I'll do is I'll jump in and show you what this looks like. So let me just bring up the server. Oops, 1 second. Okay, so this is the kind of a classic kind of conversational agent experience. I've just realized I stopped showing my screen, so let me just bring that back up. And so what I've got is some help, starter prompts here. So let's go ahead and plan a trip to a nearby city. And the agent's going to think, and it's going to stream some tokens. And what I can do is I can refresh that partway through the page, and I will still get the response. I can even, have this on multiple windows. If I bring both up. they can exist on multiple windows, and we can sort of see the conversation works multi-device by virtue of the state of the conversation being on both on the channel, which is available to both tabs. And then what I can do is send oops, I keep bringing up the wrong windows here. Apologies. What I can do is then send a prompt. So let's say I'm going to book a trip to Paris. I'm going to travel from London. I want outbound flights, a 4-star hotel. And what the agent is doing is, streaming some tokens, telling me what it's doing, and it's going to kick off some tool calls here to invoke the flight and hotel agents to search for relevant flights and hotels. And what's quite interesting is, the agent's decided here to make a parallel tool call. So it's going to delegate 2 tool calls and wait for the response. This orchestrator agent doesn't care about the intermediate results of the flight agent and the hotel agent, but I, as a user, I do care, right? I care about what the progress is. And so this progress state here is being surfaced in this case through Ably Live Objects. Let me just bring up one window. So what the agent has done is it's, searched for some flights and some hotels. It's now, got some options, and it's going to present me as a user with some options. And so what I can do at this stage is select one of those. Now, what's quite interesting here is, this is kind of an example of generative UI, it's sometimes called, where essentially the model is streaming tokens that, produce a JSON response that describes the flight options that were available. And then that's sort of rendered dynamically here in the chat window. So I can pick a flight, I can pick a hotel. And you can also see that the agent has updated some shared data here that's available to both the user and the orchestrator agent. So I can sort of see the current itinerary that I'm building up here. So you can now see that it's searching for some activities. It's kicked off a task here with the activity agent. I can see here that the activity agent is online, so that we're using presence here to show that the activity agent's online, it's processing a task. I can also see the sort of task history of what's been completed by the other agents. And so it's going to come in here and recommend some activities. I might say, wait, I want to visit a museum. So what I can do there is sort of barge in by sending a message to this orchestrator agent, and it cancels that previous task. And it's now going to refine its task and kick off a refined query here for museum activities with this activity agent. So that's an example of that sort of barge in functionality, where having visibility into what the agent was doing allowed me to interrupt the agent and ask it to do something slightly different. These sort of updates that you get from specialized agents, it's interesting to think about the different types of state that you might want to make available from agents as they execute their tasks. So, for example, you might have, the progress bar there is sort of showing pagination of the data that it's searching through, to sort of give live visibility of that. That's happening inside of a tool call. But equally, you might want to see the current thought of the model when it's then deciding what the next step is it's going to do. Okay, so let's go ahead and pick this Louvre museum activity. And what the agent will probably do now is summarize my selections, which it's done. It's going to suggest here whether we want some more activities. What's interesting is that the current selections to this agent would be available from the entire chat history. So if it were to sort of go back and look through those messages, it would be able to piece together, what I've done. If I go ahead now and say remove one of these items, so what I'm going to do now is I've got some sort of shared structured data, which I'm representing here with Ably Live Objects, and the user, removes an activity, and then I ask the agent what my current activity is. The agent has access to that shared context in order to know what my current itinerary is, even though it wasn't visible in the chat history alone that I'd removed that activity option. So you can see here now in the activity in the itinerary summary, it's realized that no activities are currently selected, even though there's no evidence of that removal of that state from the chat history itself. And so I think this goes to show sort of the importance of having to build these powerful agentic sorts of applications, that there is an understanding of some shared context about the overall application experience, and it's not just about the conversation history with the chat agent itself. So that's everything I wanted to share, really. There's lots of different ways of putting these primitives together to build these different types of applications. What we're hoping to do is to have some sort of guides that show how to combine these things to build what we see as kind of the emerging user experiences that people are building into these sorts of applications. And how to sort of remove a lot of that complexity with a sort of shared transport layer. But that's everything from me. Thanks.